Hey everyone, welcome to this video where I teach you some basics about Microsoft Excel. Um, these rules will probably follow pretty well with Google Sheets or some other spreadsheet program. You can see on the screen I have a few data points already put in. I have test 1, test 2, test 3. These are, the same sort of increments you would use in one single graph. To relate this to maybe one of the graphs you would do, this could be mass would be equal to, I don't know, 5/4. I'll just put Q. This would be a mass of 10/4, and so on. Now I'm not going to keep these up here, so I want to keep it very general. When I say test 1, test 2, test 3, think of those as the increments of your single graph. Okay, now for that specific test, I'm going to have a certain number of trials where I run that test over and over and over again. Here I've done 10 trials of that single test. Trial 1, I don't know, I've recorded 5. The units aren't important for this example. What we're going to need from these columns for test 1, test 2, and test 3 are the averages, the standard deviations, and the standard error of each test. Now, Excel can do this very easily, and I'm going to show you how we can do that. To keep things nice and neat, let's label this cell right underneath. I'm going to say average test 1. Okay, this one right here, average test 2. Right here, average test 3. Okay. Now underneath, where I have those labeled, I'm going to input the number. I could click on the cell and hit equals, and I can actually input some math in the cell. I could put in the numbers by hand. I could say 5 plus 6 plus 7, so on and so on, and hit enter, and it will add those all up, and then I could do the average by hand. I don't want to do that though. Excel has a shortcut way for me to do that. By clicking on the cell, let's click on the cell again, and I hit equals. I want this cell to equal, now let's type in average, so average, and underneath you can see a list of functions that Excel can perform. Right here I want average, double click. Now it's waiting for me to input the numbers to get an average of. Again, I could go by hand, 5, 6, 7. That may take too long if I have let's say if I had 100 trials, I might not want to do that. So let's not do it that way. Another way to do it would be just to highlight the range of numbers I want to take an average of. So let's start at the top. I click on that top value and click and drag. Now we can see all of these values are highlighted. Down below it says the average. What this is going to do, this is going to make the cell equal to the average of this range of highlighted cells. L1, 0, so L10, column L10, that's this one. The range from here to L19, right here. It's the one that's blue and highlighted. Once I have the range I want, so I hit enter, and we have an average. Okay, so I can go one at a time next cell, I could hit equals, type average again, and do it that way. But there are more shortcuts we can use. If I go on that cell, and you look up at the top, right up here, you can see where what kind of function this cell is performing. So the cell says it's giving me the average of that specific range. I can copy that function that this cell is doing to its neighboring cells. So let me click on this black dot, click and drag over, and it's copying that function to this cell and it's copying to this cell. So now if I click on this middle one, now this one's taking the average of M10 to M19. These right here. This average right here is taking the average of N10 to N19. Okay, so very easy way to, one, find the average, and two, to copy the function over to the neighboring cells. Okay, so now for standard deviation is the same exact thing. Let's type standard, actually let's put stdev1, stdev2, so standard deviation of that first test, standard deviation of second, and standard deviation of the third. Okay, the way I'm spelling it like this is because in Excel, that is what standard deviation is abbreviated as. So once again, I click on the cell I want, say I want this cell to equal, let's type in ST, and we see it's already in the list right here. So there's stdev, so standard deviation P, standard deviation S. If I click on it, it will tell me what specifically this is doing. Calculate standard deviation based on population. That's P. The S is standard deviation based on sample. That's the one we want. Double click on that. Now what's the range of numbers we want to find the standard deviation for? Same exact thing. Highlight that range. Once I'm happy, I hit enter. There's our standard deviation. Okay, I could go in and redo that function. This equals standard dev, stdev s, or just like I did on that average above, I can copy the function to the neighboring cells. Okay, so we can see it's done the function for standard deviation for all three tests. The last thing that we need is the standard error. Standard error 1, standard error 2. Standard error is a little different in that there is no built-in function for standard error in Microsoft Excel. If you don't remember what standard error looked like, the formula, we have to recreate that in here. So let me do this. So standard error, remember this formula was standard deviation over the square root of the number of trials. I'll just keep that there because we need to recreate that formula in Excel. Okay, for the standard deviation of this first test, standard error, sorry, we need to say this cell will equal, we need to have equal standard deviation divided by square root of the number of trials. We've already done the standard deviation, it's right here. So it equals the standard deviation divided by this little slash, square root of number of trials. How do we do a square root? We need to use the built-in function. It's sqrt, square root. Double click, and it's going to square root whatever number we put inside of these parentheses. So we did 10 trials, we put 10. Close the parentheses and hit enter. That is our standard error for this first test. Just like we've done before, we could copy that function over to the neighboring functions, to the neighboring cells. All right, so we have our averages, we have our standard deviations, and we have our standard errors. Let's graph this thing. I like to keep things separate when I'm using a spreadsheet, so I will make a new sort of thing I will graph off of over here on the right. I'm going to label x-axis and y-axis. On the x-axis, I want to have my independent variables, so that's going to be these increments. So I'm going to say test, and then I'm going to number the tests. 1, 2, 3. This will be your, your masses or your lengths, the thing that you control while you're changing the increments. Okay, on the y-axis, that's our dependent variable, and that's the value recorded. More specifically, that's the average value that we have found down at the bottom. So let me do average, I'll just say average value. Okay. So for test 1, the average value, I'm going to say this cell, since I don't want to type it over again, I already found it. I'll say this cell right here equals that cell. And I hit enter. Okay, those two cells are now linked. For this next one, that cell equals that cell. This one, that cell equals that cell. All right, let's graph this now that we have some data points. It may be tempting to grab all of these like this and make a scatter graph. That's some way to make a graph. It's not the best way to make this specific graph that we want to do today. The reason is, if I go like this is going to be one complete set of data. And they will all have the same standard error values on each data point. But we know that for test 1, it has this standard error. In test 2, it has this standard error. So since we want to treat these two differently, we want to treat all of these tests differently, we need to put them in separately. So let's put them all in separately, but on the same graph. So let's go up at the top and somewhere else say insert. And if you have a newer version like this, there's this tiny little button around charts. We're going to put in a scatter graph, and it's this one with just the dots. Okay. And we have this blank box that pops up. Okay, let's add some data to this table. Clicking in the middle, we now have some chart tools at the top. I want to select the data to put inside of this chart. So select data at the top. There'll be a pop-up window where we can add some new sets of data. Right here on the left, I'm going to hit add. We're going to add a new set of data. So for this first one, I could say test 1. Okay, so the x value for test 1, that's just going to be this 1 right here, because I don't have a specific value to put in. Okay, the y value that accompanies this is this one right here. And I hit this arrow when I'm done. Okay, and now test 1 data has been added to the graph. Let's add test 2. So add, let's name this test 2. And we're going to add the x values. I hit this arrow. Now it's waiting for the x value that I want. I want only this single one. And the y value, I hit the arrow. I select the y values. It's only this single point right here. And I hit the arrow and OK. All right, it has added that second data point to the table. I'm going to do this third one a little faster. This one's test 3. The x value is 3. The y value is that. Done. And OK. I have them all on the table. I hit OK. All right. So I have a graph, scatter graph, showing me the averages on this table. All right, I would be very easily convinced that this is, a downward slope. I could call it a day, say I've figured it out. It's, the case is solved. We're not done yet, though. We need to add the error bars. What's really happening here? So let's add error bars to each of these values. Okay, so clicking just in a blank area on the chart, you may see in the newer version there's this plus sign, and these are chart elements, and you're going to go and hit this arrow button next to error bars and go to more options. If you don't have that, or using something else, so let's go click on the chart, and near the top in some of the chart tools there's going to say add charts element. Let's click on that, find error bars, and we want to, error bars, here we go, more error bars options. Okay, where do we want to add the error bars? Let's add them to test 1. So I click on that, OK. And there's going to be a new window pop up for you to somewhere. Let's first, before we get there, I know in Excel, it likes adding these horizontal error bars. We don't need those. Let's get rid of those. So click on them and delete. Okay, so those are gone. We are only focusing on the vertical error bars. So I click on that, and it has some kind of options on the side. Now, whichever program you're using, you just want to find a place where you could insert your own custom value for the error bars. So custom, and specify the value that we want. Click on that, and it will give us this new little pop-up window. What's the positive error value? Now, just like we did with plotting the data points, we're going to add these error values. So I'm going to hit on that. I'm going to click this arrow, going to select the error of test 1. That's this right here. And click the arrow again. What's the negative error value? This will add the negative sign for us, and I'll just extend the bar that specific length. So hit the button, and it's the same exact error value we found earlier. And good. And hit OK. You can see the error bars have grown quite a bit since we've done that. So these are now correct for the data we have been given. Okay, let's add error bars to test 2 and test 3. So I'm going to do these a bit quicker. So just clicking anywhere on the chart, add a chart element, error bars, more options. I'm going to add error bars to test 2. We don't need the horizontal error bars. And we click on the vertical error bars to adjust them. Custom. We're going to specify that we want an error of, click on the arrow, we want that error going up, and we want that error going down. Okay. Okay, that shrunk it down quite a bit. Okay, so that's better data than that first test. Last one. Click on the charts, chart elements, error bars. We're adding to test 3. We don't need the horizontal error bars. Vertical, click on those and adjust them. We're going to specify that we want a positive error value of this that we found earlier. A negative error value of the same thing. Okay. Now that we have those all on the same graph, we have our averages and the correct error bars on the graph, we are done. What can we make out of this graph? Let me make it a little larger so we can see. Okay, well, the error bars are, decent on this one, very tightly packed on the middle one, and all over the place for that third one. In the beginning, I was almost completely persuaded that this was a downward slope. But, now I'm not so sure. This average could very easily drift down. And this average could very easily drift up a bit. And, I can't really decide anything here. In fact, if any of the error bars overlap one another, that shows us that we cannot make any decisions or we can't make any conclusions about what the data is showing. There's no difference between any of these data points. So we can assume they're all pretty much the same. That's what it means. Okay, I have another little example I've pre-made down here. What about these error bars? Okay, decent on the first one, a little bigger on the second one, and small on the third one. Okay, these error bars are overlapping on the second test, and these are overlapping down here. What can we make out of this? Well, there's no real difference between test 1 and test 2. And there's no real difference between test 2 and test 3 because the error bars are overlapping. But we can say test 1 and test 3 are thoroughly not overlapping one another. So we have to ignore this middle test to then make any kind of assumption about what the data is doing. This means we have, lesser quality of data. So this is the more unsure sort of answer. The third type I have down right below that is the best type of data, where the averages are set and the error bars are very tightly packed. We can see that none of these error bars overlap one another. So I can say for certainty there is this downward trend happening. Okay, I believe this was a good beginning tutorial for Excel. Hopefully we've learned a bit about functions and making graph with correct error bars.